Hello everyone, let's start with the topic sequence in series. Okay, so what is a sequence? Sequence is a set of numbers in a given order or follows a particular pattern. For example, if you observe this pattern, this 2, 4, 6, 8, 10. So these are following a particular pattern. If you see, there is a jump of 2, means plus 2, plus 2, plus 2, plus 2. So this is following a particular pattern. So this is a sequence. Similarly over here, this is a sequence because this is also following the pattern of plus 2. This is of a sequence because this is following a pattern of divide by 2. So throughout the series, a particular pattern is being followed. This is also a sequence. This sequence is a special sequence known as square number sequence. So this is 0 square, 1 square, 2 square, 3 square, 4 square, and so on. This is also a pattern, and this is a sequence of plus 3. This is also a pattern. In this, the sequence is following a pattern of negative 4, or we can say subtracting 4. So all these are known as sequence, means any given number series which follows a particular pattern is known as sequence. Okay, so in this chapter we'll learn about uh, special sequences. So before that, when the terms of a sequence are added together, like 2 plus 4 plus 6 plus 8 plus 10, the resulting sum is called series. Okay. The process of adding the terms together is called summation, which is indicated by this symbol sigma. This is a Greek letter word sigma, summation, which represents summations. Okay, so now we are going to study about a special series which is known as arithmetic sequence. So what is arithmetic sequence? A sequence in which the difference between any two consecutive terms, means a sequence in which the difference between any two consecutive term is constant throughout the sequence, means a number sequence or a given sequence in which the difference between any two consecutive term is constant. We can say that the given series is a arithmetic sequence or arithmetic series. For example, if you see what is the difference over here, this is plus 2, plus 2, plus 2, plus 2, plus 2. So if I see difference between any two consecutive terms is constant, so I can say this is a AP, arithmetic progression. Similarly over here, the difference between this is plus 3, over here is plus 3, over here is plus 3. So this is also an AP. Whatever the difference over here is, difference over here is zero point 0.5, zero point 0.5 means plus 0.5, plus 0.5, and this is constant throughout the series. So we can say this is also a AP. What about this? What is the difference? Is it constant over here? Yes, the difference over here is 0, which is also a constant. So this is also an example of AP. What is the difference over here? This is negative 2, negative 2, negative 2, and negative 2. Is this is a AP? Yes. Why? Because the difference is constant over here. So what's our observation from the following number series? That we have seen the difference in the first series was positive, difference between the second series was positive. This was kind of a decimal or rational number, we can say. This is constant 0, and this is negative. So our observation is that our difference can be any real value, means difference belongs to R. It can be positive, it can be negative, it can be a rational number, means basically a real number. All this comes positive integer, negative integer, rational numbers, all this comes in a real number. Even it can be an irrational number. Okay, so now the next thing comes is the notations. So what are the notations we will be using in this is common difference, which is denoted by D, first term, which is denoted by A or A1 and represents the number of turn, or AN, or in some books you will find it's written as UN. So what does this mean? That the general term of that given number series or number sequence, or AN represents the nth term of the series. Okay, now let's see the general form of the series. Let's suppose my first term is A. So what would be my second term? A plus D, because there would be a common difference. we are jumping it by the common difference. What would be the third term? A plus 2d. Again we are adding the common difference over here. What would be the fourth term? A plus 3d. Similarly, this is my first term. I can write down this as either u1 or a1. This is my second term, u2. This is my third term, u3. This is my fourth term, u4. Now can you observe the pattern in this and can you figure out what would be un, nth term? So if you observe, the a remains constant throughout the series. So this would be a plus. Now in our first term, there was no difference. In the second term, difference is there, that is 1d. Third term, 2d. Fourth term, 3d. So nth term would be n minus 1d. So this is our general formula representing either an, means which represents a plus n minus 1d. Means any given term in the series can be represented in this form. Let's suppose if someone say what would be the sixth term, so a6 would be a plus 5d. What would be 25th term? That is a plus 24d, and so on. So this is our general formula, and this formula is given in your formula booklet, or it's very easy to remember. It's just the simple logic, a plus n minus 1d. Okay, now let's apply this formula in this question. So what is the question? Find the 17th term in the given sequence. So first thing, what is the first term over here? A1, that is 12. What is the difference over here? That is difference of two consecutive terms, so which is negative 3. Okay, now what is our formula? Any given term in the series can be given by a plus n minus 1d. So we need to calculate the 17th term. So n is equals to 17, which is equals to a. A is your 12. A represents the first term plus n. N is 17 minus 1 times negative 3. Difference is negative 3. Now this we can simplify. This would be 12 plus 16 times negative 3. So which can be further simplified. 12 plus 16 times negative 3, which means 12 minus 48, which gives us negative 36. Means if we keep on following this pattern, means if we keep on decreasing the terms by negative 3, so there would be a 17th term whose value would be negative 36. Okay, so now next, in this is the same formula we'll be using to find out the number of terms in the given sequence. Okay, the idea is same. First, what is the first term? A1 or A, which is 11. What is the difference over here? Is 15 minus 11, which is equals to 4. And what is the nth term? We don't know which term is this, so I am writing this down as an, nth term, that is 643. Now what's our formula? An is equals to a plus n minus 1d. Now the first thing over here is an, that is 643. What is your a? First term is 11 plus n minus 1d. We don't know what is the value of n minus 1, and we know the difference is 4. Now just the simple algebraic calculations we have to do. That is 643 minus 11 will give us 632 is equals to n minus 1 multiplied by 4. Now this will give us n minus 1 is equals to 632 divided by 4. So 632 divided by 4 will give us 158. So n minus 1 equals to 158. So n equals to 159. So which implies that the number of terms in this given sequence is 159. Now the most important thing that we have to note over here is number of terms in any given series is a natural number. Why? Because we can't have number of terms in negative. How would you define negative 2 terms? Or how would you define 2.5 terms? So number of terms would be a counting number. So counting numbers are also known as natural numbers, means 1, 2, 3, 4, 5, 6, 10, 15, 35, 45, 90, and so on. So this is the most important point over here, that the number of terms in any given series is a natural number. Okay, so I hope you are clear with this idea. Okay, now let's go to the next part of the topic, that is sum of terms of an AP. So sum of terms of an AP means, let's suppose if you want to calculate the sum of this given terms, this given sequence. So how would you calculate this part? So let's find out. Okay, now the notation part, let's suppose Sn denotes the sum of n terms. What does Sn represents over? S represents sum, n represents number of terms. Okay, now the general form of an AP can be written as, let's suppose if my first term is A, second term would be A plus D, that is the common difference. Third term would be A plus 2D, fourth term would be A plus 3D, and so on. Now what does S1 means? Sum of first term. S2 means sum of first two terms. So first term is A, second term is A plus D. So this is the sum of two terms. S3 means sum of first three terms. Similarly, Sn means sum of first n terms. Okay. So this is what we have understood. What does Sn represents? Okay. Now how to figure out? One way of doing is you start adding the terms in calculator. So that is one way of doing it. Or the second way of doing it, let's derive a formula or let's verify a formula how this is working logically over here. So one way of doing it is using logic. Let's suppose this is the given series, okay, and you need to find out the sum of all the numbers in the given series. Okay, first figure out, is this AP? Is this is an AP? Yes, yes, this is an AP because the difference between any two terms is constant, that is plus 2. Okay, now to figure out, we need to find out the sum of this. One way of doing is using calculator, you start adding 2 plus 4 plus 6 plus 8 plus 10 and keep on adding till 98 and figure out what is the sum. Other way of doing it, let's start with the simple part logically. So what I am doing is, what is the sum of first and last term? That is 2 plus 98, which is 100. Okay, what is the sum of second and second last term? That is 4 plus 96, which is also 100. Now what is the sum of third and third last term? 6 plus 94, which is also 100. So are you observing a pattern? Means the first and last term add up to 100, second and second last term in this series add up to 100, third and third last term in this series add up to 100. So how many pairs of number adds up to 100 in this given series? So how many pairs you will have? This is one pair, this is two pair, this is third pair, fourth pair. Similarly, you will get a pair which add up to 100 till 40, till, because 50 would be the middle term, there would be no pair for 50. So before 50 you will get all the numbers which add up to 100. Okay. So in that cases, how many pairs are we getting over here is 24 pairs of 100 plus 150. Okay, so this will give us 2400 plus 50 is 2450. So this would be the sum of all the numbers. Okay, now if you observe, what we have used over here is, I am using the concept of average. Okay, so what is the average of first and last term is 50, second and second last term is 50, third and third last term is 50, fourth and fourth last term is 50. Similarly, how many 50s would be there? Means you can understand this as this way. Let's suppose the first term So I am subtracting 48 out of it and giving this 48 to 2. So both of this term becomes 50. Means if you subtract, I will use different color over here. If you subtract 48 from here and if you give 48 to this, so there is no overall change in the equation because you have subtracted 48 and you have added 48. But by this first term becomes 50, last term also becomes 50. Similarly over here, if you subtract 46 from here and if you give 46 over here, now the second terms also become 50 and second last term also becomes 50. So how many 50 would be there in this series? That would be 49. And how many times 50 is there? 49 times 50. Simply 49 times 50 will also give you the same answer. So if you multiply 49 into 50, this also gives you the same answer, 2450. Now relating this to our formula, so what I did was, how can I write down? 49 is how many number of terms are there. So I can write down this as n number of terms. And how we got the 50? That is the first term and the last term. That is A plus L. A represents the first term, L represents the last term, divided by 2. So this is our formula for sum of n terms in the given series. This formula can be written as in different ways, which we will observe right now. This can be also written as, because last term is also denoted by an can be written plus a plus n minus 1 times d. Now if you substitute this value in this formula, this will simplifies to Sn, means sum of Sn, that is sum of n terms, would be n by 2, 2 times of a plus n minus 1 d. Okay, both of these formulas are given in your formula booklet MF9. Okay, so this was the logic. We'll try to figure out how we use the concept of average to figure out a sum for any given series. You can use this average concept. If you are not able to remember the formula, you can use this average concept, and if the given series is in AP, you can easily figure out the formula. Okay, now let's generalize this formula by writing the series in conventional notation. So sum of n terms, a, first term, second term is a plus d, third term is a plus 2d, and so on. So I'll also write down this as Sn again. Now what I will do is I will reverse the order. Reverse the order means, what is the last term? I am writing this down as the first term, a plus n minus 1. Similarly, this would be a plus n minus 2 b, and this will go on till the last term is a. Now what we'll do is we'll add the sequence, both left hand side and right hand side. So this is Sn, this is Sn, so I can write down this as 2 times of Sn. Sn plus Sn is 2 times of Sn. Now if I add this term and this term, so if you simplify, this is a plus a will give you 2a plus n minus 1 d. Plus, now if you add this two term, a plus a would be again 2a plus, in this case there is plus d, there is negative 2d. So ultimately simplifies to negative 1d. So which can be written as negative n minus 1. Similarly, if you add up, what would be the last term? 2a plus n minus 1 d. So if you observe, all the terms are adding up to the same value. Now how many times is this value? This is 1, 2, till how many times? Since our sequence is still n terms, how many times are this? This would be n times. Let's suppose if you are adding 3 plus 3 plus 3 plus 3 till 3, and how many times are there? Let's suppose these are n times. So this can be written as 3 times n. The same logic we are using over here. So I can write down 2 times of Sn, n times 2a plus n minus 1 d. Now since you need to find out the formula only for Sn, so I will just rearrange this and make Sn my subject of the formula. So n divided by 2, 2a plus n minus 1 d. So if you see, this is the same formula which we have written over here. Sn is equals to n by 2, 2a plus n minus 1 d. So either you can go it by logically or by the conventional method. Though the derivation is not required, but it's good to know the derivation part. Just what we need to do is we need to apply this formula and we need to solve the given questions or problems. Okay, now this same formula can be written as n by 2. I can write down 2a as a plus n minus 1 d. Okay, now this is an or last term, so which can be further written as n by 2 a plus l, where l represents last. Okay, so I hope we are clear with this formula. Okay, now let's see how to apply this formula. Find the sum of first 100 natural numbers, means 1, 2, 3 till 100. So sum is, told you how many numbers are there, n, 100. What is the average? 1 plus 100 by 2. So if you simplify this, this will give you 50. This is 50 times 101, which is 50 or 50. Okay, simple. Or you can directly apply the formula. This will also give you the same answer. Okay, now let's see this question and we apply the formula over here. The sum of first 100 terms in the given progression. Okay, so in this case we don't know the last term, so we can't use this formula. Which formula? Sn is equals to n by 2 a plus l, because for this formula we need to know the last term. So in this, which formula we will use? N by 2 2a plus n minus 1 d. Okay, now first thing, the notations part. What is a? A is the first term. What is difference? Difference is 1 by 4. Now difference you know, and n, how many terms? 100. Okay, so this is the given information. Let's substitute it in the formula. A, n is 100, so 100 by 2. 2 times of a, that is 2 times of 1, plus n minus 1, so n minus 1 would be 99, divided by, sorry, multiplied by d. D is 1 by 4. So this gives us 50. This gives us 2 plus 99 by 4. Now if you simplify this part, this gives us 50 into 107 by 4. Now this can be further simplified. 50 into 107 gives us 5350, divided by 4. Divided by 4 will give us, that is 1337.5. So this is the sum of first 100 terms in the given series. Okay, I hope you are clear with this idea. Chalo, now let's move on to the next type of sequence, that is geometric sequence. So geometric sequence is a sequence in which the ratio, in this, if you observe, ratio of any two consecutive term is constant. So in AP, the difference between any two consecutive term was same. In this, the ratio of any two consecutive term is constant. So what do you mean by the ratio? Means the second term divided by the first term. Now if you see, 4 divided by 2 gives us 2. Now this 32 divided by 16 gives us 2. So now in this, 6 divided by 3 gives us 2. Now 12 divided by 6 gives us 2. The ratio, this ratio is also 2, this ratio is also 2. Or simply I can write it down. 3 multiplied by 2 gives us 6. 6 multiplied by 2 gives us 12. 12 multiplied by 2 gives us 24. 24 multiplied by 2 gives us 48. Similarly over here, this is divide by 3. Negative 216 divided by 3 is negative 72. Negative 72 divided by 3 is negative 24. Negative 24 divided by 3 is negative 8, and so on. So if you see, the ratio is same. In this case, you can say this is multiplied by 5, multiplied by 5, multiplied by 5. In this is multiplied by negative 1, multiplied by negative 1, multiplied by negative 1, and so on. So a sequence in which the ratio of any two consecutive term is constant, we can say that the given sequence is a geometric sequence. Okay. Now, the sum of terms of a geometric sequence, is called geometric progression. Okay, which can be written as GP. GP means geometric progression, or the alternative name for this given is geometric series. And what is geometric series? The ratio between any two consecutive term is constant. Okay, now the notation which is similar. Now the first term is A, number of terms is N. Only difference is in AP there was common difference. Over here there would be a common ratio which is R. Now AN or UN, different books denoted differently. Either you can say the general term or nth term in the given sequence. Now for example, this is an GP. Is this a GP? Let's figure out. This is multiplied by 2, this is multiplied by 2, this is multiplied by 2, this is multiplied by 2. Or if you take a ratio of any two consecutive terms, 6 divided by 3, 12 divided by 6, 24 divided by 12, or 48 divided by 24, which gives you the common ratio is 2. Okay. Now write the general term of the given sequence. Okay. Now what is the general term of this given sequence? How would you write down? Okay, the ratio is same. So what I am doing is every time I am multiplying this by 2. Okay, so I can write down 2 to the power n. Let's suppose if I write down 2 to the power n, is it first term? Did I multiplied the first term by 2? No, my first term is 3 and the second term is 6, means second term I have multiplied it by 2, so I can write down this is this. Now let's verify. This is my general formula. Now if I substitute n equals to 1, 3, 2 times of 1 minus 1, which is 0, 3 into 2 to the power 0, which is 3 into 1, which is 3. Okay, let's verify. This is my first, second, third, fourth, fifth term. Okay, so I will write down A5, that is 3, and ratio is 2. So fifth minus 1, so which is 3, 2 times 4. So 2 times 4, so 3 into 2 times 4 is 16, 16 into 3 is 48. Okay, so this is my general term formula for the given sequence. With this formula, I can calculate the value at any given point. Means if I need to calculate the value, what would be the 20th term? Simply I have to replace this as a 2 to the power 19. This will give me the value of what would be the value in the 20th term. Okay. Now find the 7th term in the geometric sequence. Okay. Now formula, I have not told you the formula yet. Before writing down the formula, we are doing it logically. So what is this? Multiplied by 3. So every step we are multiplying it by 3. So I can write it down as 3 to the power n minus 1, because first step we are not multiplying it by 3, we are starting multiplying it by the second step. So it's n minus 1. Okay, what is my first term? First term is 8, so I have to multiply this whole by 8. Now let's verify if this is my formula. A 2. So second term A 3 to the power 2 minus 1, which gives me 8 times 3, which is 24. 24. Done. Now let's verify for one more, that is A4, means fourth term. A 3 to the power 4 minus 1, which is 8. 3 to the power 3. So 3 to the power 3 is 27. So 27 into 8, 27 into 8 gives me 216. Okay, so this is my fourth term. Means this So the general formula for the given sequence is this: a n minus 1, 3 to the power n minus 1. Okay. Now, how can I write down the general formula for this given any given EP series? Sorry, GP series. General formula. So if you observe an, what is 8 over here? First term a. What is 3 over here? The common ratio n minus 1. So this is the general formula in any given GP series. So a is the first term, and r is the common ratio, n minus 1 means number of terms minus 1. Okay, so I can write it down there. First term, r is common ratio, and n is number of terms. Okay, now the sum of terms of a GP. The general formula. Let's suppose this is a, so I have multiplied it by r, multiplied it by r, multiplied it by r. So what would be my nth term? Means let's suppose this is my first term, this is my second term, this is my third term, this is my fourth term. So what would be nth term? So I kept a is multiplied by each and every term. So a, r is there. Now over here, first term r is 0, second term r to the power 1, third term r to the power 2, fourth term r to the power 3. So nth term r to the power n minus 1. So my general formula an is equals to a r n minus 1, which we have already seen. Okay. Now the thing comes over here is sum of n terms. Okay. Now this part, last term would be a r to the power n minus 1. Okay. Now what we are doing over here is we are figuring out how to calculate the sum of n terms. Okay. This part, this calculation or this simplification, it's not necessary to know, but it's good to know. So what I will do is I will multiply the whole sequence by r. Okay. So what I can do is I can write down this r times of Sn. Now if you multiply a into r, it would be ar. So instead of writing it over here, I'm just writing it one step ahead, ar. This would be ar square. Means I have written this over here, multiplied by r. Similarly, this would come over here, ar cube, and so on. There would be a term ar n minus 1, plus there would be a term ar n, because when you multiply this term by r, you will get this. Now what I will do is I will subtract the terms. Subtract from the above equation. Now this would be Sn minus r times of Sn. Now there is nothing below over here. This would be a. This would be ar minus ar, which is 0. I can cancel it out. Ar square minus ar square, which is again 0. Cancel it out. This cancel it out. And this last term cancel it out. We are left with negative a r to the power n. Now if I take Sn as common, so this would be 1 minus r. Now this can be, if I take a common, this would be 1 minus r to the power n. Now we need to find out sum of n terms. Sum of n terms is a 1 minus r to the power n divided by 1 minus r. So this is the formula of sum of n terms of an geometric series or geometric progression. Now let's apply this formula over here. Find the value. So you need to calculate the sum of this. Okay. Now first we need to figure out how many terms are there. So first we need to find out this n. So how would you figure out n? From the first formula, means an is equals to a plus an equals to a times r to the power n minus 1. Okay, so this was our first formula. In this, what is a? 0.2. What is the common ratio? 5. multiplied by 5, multiplied by 5. Okay, so what is an over here? Means my last term in this sequence is 390625. So I will just substitute this values over here. So this values over here, if I substitute, now this would be 39625 equals to 0.2 times 5 to the power n minus 1. Now if you simplify this, 5 to the power n minus 1 is equals to 39625 divided by 0.2, which gives us 39625 divided by 0.2 gives us 1953125. 1953125. Okay, now 5 to the power n minus 1 gives us 1953125. Now we need to calculate. So over here what we can do is we can take one more concept we can use, that is either you can use trial and improvement. So what is trial and improvement? So you need to figure out which power of 5 gives you this value. So randomly you have to start with. So let's suppose if I start randomly, means both the answers will give us the same, 5 to the power 20 if I start randomly. So this would be a too big value, so I'll start with 5 to the power 10. So 5 to the power 10 trial and improvement gives me 9765625. So which is a bigger value, means I have to change from this to 7, let's suppose. So 5 to the power 7 gives me 78125. Or now again this is a smaller value, so now I will check for 9, 5 to the power 9. So 5 to the power 9 gives me 1953125. So I can replace this as 5 to the power n minus 1 equals to 5 to the power 9. Now base is same, so I can just equate the powers. So n minus 1 equals to 9, so n equals to 10 over here. This is one way of doing. Or from here what we can do is taking log both sides from this part, from this equation. So this would be n minus 1 log 5 is equals to log 1953125. So n minus 1 is equals to log 1953125 divided by log 5. So let's just calculate log 1953125. You can use calculators over here. Divided by log 5 gives you 9. Okay, so if n minus 1 gives you 9, so which simplifies n equals to 10. So in both the scenarios your answer would be same. Okay, so now the thing comes is one more concept over here is, that is infinite geometric series. So right now what we have done till over here in AP and GP is finite GP series or finite series. We have been working on finite, where the number of terms in the given sequence was finite. So we were calculating the given term for the finite series, sum of terms for the finite series. So now in this we'll work on infinite series. So in infinite series we need to know the two terms, one is convergent series and one is divergent series. So now what is convergent series? So the word converge itself means it's derived from the word converge, means it's converging towards a point. Okay, now this can be written as 0.5 to the power 1. This can be written as 0.5 to the power 2. So this can be written as 0.5 to the power 3. And similarly, if you write down 0.5 to the power 4, 0.5 to the power 5, so 0.5 to the power 4 would be 0.5 to the power 4 would be 0.625, 0.0625. Now again, this would be multiplied, if you do again this 0.5, so this would be 0.3125. Now let's suppose if you take 0.5 to the power 10, so 0.5 to the power 10, so this would be 0.00097656625. So what's our observation? If you keep on increasing the numbers, means power, so the value is approaching towards 0. The value is approaching towards 0. So let's suppose if in a given series, this is my common ratio. So r to the power n means common ratio to the power number of terms. In that scenario, if my number of terms is approaching towards infinity and my r is less than 1 but greater than 0, you can see, or mod r is less than 1, we can see, I can write it down as mod r, modulus r is less than 1. So in that scenario, and number of terms is tending to infinity, so I can write down r to the power n will be reaching to 0, but it will not be exactly 0, but it would be near to 0. So in that scenario, what things changes over here is my sum of n terms of n GP is a 1 minus r to the power n divided by 1 minus r. So considering this scenario, if I need to calculate the sum of infinite terms of n GP, infinite terms means number of terms standing to infinity where r is less than 1, so r to the power n will be reaching to 0. So in that scenario, this would be approximate 0, not exactly 0. So I can write down this as 0. So 1 minus 0 is 1, a times 1 is a. The sum of infinite terms in a given series can be given by this formula. So condition n is approaching infinity and r is less than 1. Mod of r is less than 1. Okay. Now let's apply this formula over here. So find the sum of terms of infinite progression. So this is my first term, a is 0.2. What is r? So r is 1 by 10, so which is 0.1, and n is infinite, so n equals to infinity. So sum of infinite terms of n GP is given by a upon 1 minus r. So which can be written as a is 0.2 and 1 minus 0.1, so which is 0.2 divided by 0.9, which is 2 by 9. Sum of infinite terms. Okay, so by this we have seen what are the concepts involved in this chapter and some of the questions. We have solved some of the questions related to the same. So I'll just share the summary over here. So I'm just writing it down over here in AP and GP. So the first time, any given A, general formula or generally how we represent any given AP series, A plus n minus 1 B, and any given term can be represented by this given formula where a is the first term, n is number of terms, d is the common difference. Now sum of n terms can be written as n by 2 a plus l. This is one of the formula where n represents number of term, a represents first term, l represents last term, or it can be represented as n by 2 2 times of a plus n minus 1 b. Okay, now in GP we can represent any given series by AR, AR square and so on, AR to the power n minus 1. Okay, in AP the common difference of any two consecutive term was same. In this GP the ratio of any two consecutive term would be the same. Any given term in the GP can be represented by AR to the power n minus 1. Now sum of n terms of an GP is given by the formula A 1 minus R to the power n divided by 1 minus. Now the sum of infinite terms of an GP can be given by the formula A upon 1 minus R, and the condition is R is less than 1 and n is tending to infinity. So this formula works. So all these formulas are given in your MF9 formula booklet. Just we need to understand how to apply this formula in a given questions. Okay, I hope you are clear with the concepts involved in this chapter. Thank you so much. I hope you have enjoyed this video.